Hello and welcome. My name is Harshit Daga and I work as a senior software consultant at Noldas. In this series of Scala 3 video, I'll be talking about extension methods. Extension methods are used to define the additional features outside the class definition, and you use those additional features as if they were always defined within the class. For example, I have a list of integer values, and what I do is I want to check if all the elements inside the list are non-negative integer values. Okay, so to check this, I use for all method, which takes a predicate, and it checks every value inside the list against this predicate. Okay, and if I take another list which is an empty list dot empty of same type integer, and if I apply same for all method here inside for all method here with this empty list also, so what should I get in this case? Let's see what compiler has to say. Strange, because this also gives you true, having known that this is an empty list. So ideally what you would want is, like, if this is an empty list, so we should be getting a false, but this is not the behavior of for all. For all works as if your list is empty, so it will give you a true response. So this is not for all what we wanted. So what we wanted is, like, for all should return false if there is an empty list, otherwise it should behave as it is. So what we can do is here we can use extension method to define our own version of for all. I'll show you how. Extension over list. Okay, and what I can do is here I can define a new method here which will be for all version 2, and what it will do is, like, it will take a predicate, return type will be boolean obviously, and what we want is if it is an empty list, so give me false, and if it has some values here, if it is a non-empty list, so behave as it is, list dot for all, and apply this predicate here. Okay, I think this name will clash over with this list, so I'll do is I'll make it L. Okay, and now what I can do here is I can use the same list object against my for all v2. So what I can do is, like, list dot for all v2, and let's see what output do we get here. Yes, so for all v2, if this is a non-empty collection, so it should behave as it is, and let's see what happens if it is an empty collection, which is list1 dot for all v2 underscore is greater than 0, and if we run here again, yeah, so here as you can see you got false here. So this is how, like, you can use extension methods, and the advantage of using extension method over your object, over your class, is that the extension method is used as if this extended method was part of your class definition only. So while using this extension method here, you actually were using with the dot operator, like object name dot the method name, which you generally use when your method or when your definition is inside the class. So this is what extension method gives you for. And like in general, when you use extension methods, so basically they may be inside some other object. So what you can do is like you can use extension method like this. You can put it inside a new object, list extension maybe, and add an extension method here. And then next what you can do is you can import list extension as here and use your extension method as usual. Okay, if you want to add a few other extension methods here, for example, let's say if this is a list of integer and you want one more extension method here, average of all the elements inside the list. So what you can do is you can do again the same thing. If this is an empty list, so the average should be 0, and sorry, not list, L. And if this is a non-empty list, so what you would want is L dot sum divided by 1.0 1 into L dot size. Okay, and if you do here L dot average, so this is how average method that is added as an extension method to the list of integer works. The average of first 4 number is 1 plus 2 plus 3 plus 4, which is 10. 10 divided by 4, which will give you 2.5. So this is the another method like that you can add over the list of integers. Okay, so extension methods is not a new concept with the Scala 3. It's just the name it's just the keyword extension, which is a new thing. So prior to Scala 3, that is in Scala 2, you used to use this extension method using implicit classes, and the pattern is generally known as pimp my library. Pimp my library is if you say extension method, if you say pimp my library, so they both are referring to the same thing. And moreover, like the underlying changes is like by using pimp my library, so you used to define implicit classes, but when you use extension methods, so it's not like that compiler creates a new class for you. It's just like it adds a few curried methods within the same object, and it adds a few curried methods. So first, the first argument would be the list of integer for that curried method, and the second argument will be the argument which comes from here. So if I show you how this extended method will be internally rewritten, that would be something for all v2 extension, and the first is list of integer, and second is predicate, which is from in boolean, and rest is same. So the rest is same. So this is how extension method is internally transformed like this. and if you call this extension method from outside this object, so what compiler desugars this statement to something like for all v2 underscore extension list 1, and then your predicate, which is underscore should be greater than 0, or like integer should be greater than 0. So this is how extension methods are desugared by the compiler. And like as you can see, there's no implicit classes here, so it's much more lighter than implicit classes, because you don't want to have a new class for extending feature of existing objects. So yeah, that was all from extension methods in Scala 3. Hope you like this video. Thank you very much.